Okay, so now we're looking at some conditional statements, converses and contrapositives, and we're going to extend to some more proofs in that sense as well. So what's a conditional statement? So a conditional statement is if it's in the form if, then. So there's a condition put on it. If something is true, then the result is. The statement following if is called the hypothesis. You can relate this to science, right? So your hypothesis, what's going to happen, or if this does happen, and then the then is called the conclusion, the result. In the conditional statement, if a number is positive, then the square of the number is positive. The hypothesis is if a number being positive. So, given that you have a positive number, conclusion is the square of it will be positive. Is this true? Yeah, the square of actually positive and negatives is positive, so yes. Okay, now 0 stays the same, but that's not what it was asking. Write each of the following as a conditional statement. So, so we've given all poodles are dogs. So you would think back, okay, what are poodles and dogs? They're animals. So if an animal, oh, that's, just give me a second here. So if an animal is a poodle, then it is a dog, is an if-then statement. If an isosceles triangle has two sides of equal length, to put it into a conditional statement, you would say, if a triangle is isosceles, then it has two sides of equal length. And I try to use similar wording to what was given. Okay. So what's the converse of a statement? The converse of a conditional statement is written by interchanging the hypothesis and conclusion. So just remember, the if and then stay where they are. You interchange the hypothesis and conclusion. So if a number is positive, then the square of the number is positive. Okay, that we already did that one. That was our conditional statement. State whether the statement is true or false. Okay, so we already decided that one is true, right? Write the converse. So if the square of a number is positive, then the number is positive. Okay. State whether the converse is true or false. If false, provide a counterexample. So the square of a number is positive. The number is positive. So we know that 4 squared is 16, for example. But the square of a number, if that's positive, so we've got something squared. So something squared has to give me a positive. Okay. Is that true for this number here, right? Are we always going to get this original number being positive? Well, think about it. What if I put in -4? Do I get a positive? Yeah, I get 16. 16 is the square, so the square of a number is positive. -4 squared is 16. The number is positive. It was negative, right? So this is false. So a counterexample would be something like this. So that's positive, but -4 is less than 0, right? It's not greater than 0. Okay, so that is your counterexample. What's a biconditional statement? If a statement and its converse are both true, and we can combine the two statements into a biconditional statement. And we call it an if and only if, and it's abbreviated to IFF. If. You say it longer, right? So if you see that in any statement, it means you can reverse the hypothesis and the conclusion, and both will be true. So if two sides of a triangle are congruent, then two angles of the triangle are congruent. Okay, so the converse, if two angles of a triangle are congruent, then two sides of a triangle are congruent. And hopefully you remember that back from junior high, right? The angles opposite equal sides are always equal. The sides opposite equal angles are always equal. So the biconditional statement, okay, you can go back to the original and then you drop the if and then. You say two sides of a triangle are congruent if and only if two angles of the triangle are congruent. Okay. So this kind of replaces the then, but you drop the if. So it means both ways. Contrapositive. So that's something that it's maybe a new word for you. So done statement, if P, then Q, right? So this is just a general example. Converse, remember, would be if Q, then P, right? This is your hypothesis, this is your conclusion, so you interchange them. The contrapositive is where you negate the converse. So if not Q, then not P. So I always, if you're asked in a, say for example in a test for the contrapositive, I start with the statement, I find the converse, and then I do the contrapositive. I try not to skip because maybe I will get them mixed up. So even though it might all be true, each statement, you got to have the wording correct. So write the contrapositive of the following conditional statement. If Mary goes to the party, then the little lamb will go to the party. So there's your initial. So my converse, as I said, I go through everything. If the little lamb goes to the party, then Mary goes to the party. Okay, so then contrapositive, if the little lamb does not go to the party, then Mary does not go to the party. Okay, that's the contrapositive. All right, angle ABC, angle C is 90 degrees, so it's a 90-degree triangle. Write the Pythagorean theorem as a conditional statement. So basically, if angle C equals 90 in triangle ABC, then C squared equals A squared plus B squared, right? We know that the sides will satisfy the Pythagorean theorem. Write the converse. So if C squared equals A squared plus B squared, and that could be in triangle, keep in triangle ABC, then angle C equals 90 degrees. And then write the contrapositive. If c squared is not equal to a squared plus b squared. So we can use that symbol in triangle ABC. Then angle C is not equal to 90. So if it's given with equals to start, not, you don't have to use the word not, you can use the slash. Okay. Next one, consider the following. Multiples of 4 are always multiples of 8. So write this statement as a conditional statement. Is it true? Okay. So, if a number is a multiple of 4, then it is a multiple of 8. And then it says, is it true? So if a number is a multiple of 4, then it's a multiple of 8. Well, what are multiples of 4? So 4, 8, 12, etc. Well, not all of those are multiples of 8. Okay, so this is false. Counter example would be 12. Okay. Write the converse. If a number is a multiple of 8, then it is a multiple of 4. Is that true? Well, multiple of 8 would be 8, 16, 24, etc. Those are all multiples of 4, so that is true. Okay. Contrapositive. If a number is not a multiple of 8, then it is not a multiple of 4. Okay? Well, not a multiple of 8. So that could be 1, 2, 3, 4, 5, 6, 7, 9, 10, etc. Then it is not a multiple of 4. Well, these ones aren't multiples of 4, but this one is, right? So this is actually false. So false, okay? For example, 4, the next one would be 12, etc. Okay? So what you'll find in, if you look at a conditional statement, the converse, and then the contrapositive, if the original is false, the contrapositive will be false. May be false in between, may be true, okay, in the converse. If the original is true, then contrapositive will be true. Okay, so if we look back at this, if this is 90 degrees, then the sides will satisfy this. That's going to be true. Now here, if this is true, then that has to be 90 degrees. That is true. We know that even from Pythagorean triples. If this is not true, then we know that that can't be 90 degrees. Okay, so all three of those are. All right. Then, was there another example here? Well, let's kind of marry those a little, but those are the mathematical ones. So original, true, then the contrapositive true. Original, false, contrapositive, false. What happens in between in the converse doesn't necessarily tell you. That's it.